Okay, so I just finished with number 23. I'm working on number 24 right now, and that's going to be very similar to number 22, where I've got two tangents. And I'm going to label my missing piece as x. And then this portion over here, the major arc, is 360 minus x. So my angle equals half of the major, which is the whole 360 minus x, and then that minus the minor, which is minus x. So I'm going to just think of that as 360 minus 2x, and half of 360 is 180, and half of 2x is just is x. So subtract 180 from both sides, and we get 71 minus 180. Negative 109 is negative x, so x is 109. And last 125, we've got an inscribed angle, which is half of the arc that it cuts off. So that'd be 89. Next section is to find the sector area, which we kind of studied at the beginning. But we have a formula for that. We just take our angle out of 360, and since we're doing area, we want to use pi r squared. The radius in this case is 15. So now I can plug in 90 out of 360. Then I'll multiply that times pi times 15 squared. 176.7. And that's miles squared, or square miles. Then in number 27, I'm going to use the same formula. So I'm going to find the fraction out of 360 times pi r squared, since I'm doing area this time. And 30 out of 360 is, I don't have a fraction calculator here, but if I reduce that, it's 1/12. Not that you have to do that, but you can use your calculator. And again, my radius is 15. So I'm going to just do the math there. 15 squared times pi times 1/12. I get 58.9. Okay, for the next few problems, I've gotten out my book to remind myself of the formulas. You probably want to have your flip book out for this too, just so you can tell. In number 28, for example, we've got a secant and a tangent. So the formula I want to use for that is the secant tangent formula. So I'm going to take the two lengths of the secant, so 12 plus x, and then multiply that times y, which is the portion that's outside the circle, equals the tangent value squared. So once I have everything substituted in, I just want to use my equation solving skills, and I'll distribute 18 squared, 324. So to isolate x, I need to subtract 144 from both sides. 12x equals 180. Divide that out, I get 180 divided by 12, 15. In number 29, we've got 2 secants. So that's going to be this formula here. We add up the 2 lengths on one of the secants. So I'll do the one 8 plus 10. And we multiply it by w, which is the portion outside the circle. Then now I'm looking at y plus z. So that's here, the 9 plus x. Then you multiply it by the portion outside the circle. So that's the 9. So once you've got everything plugged in, it's just a matter of using your equation solving. So 8 plus 10, that's 18 times 8 equals 81 plus 9x. So 18 times 8 is 144. I'm going to subtract 81 from both sides. That's 63 equals 9x divided by 9, and I get 7 for x. In number 30, I've got the exact same type of problem. I've got 2 secants, so I'm going to use the same formula that I used in the last one. So I add the lengths, then I multiply by the part outside, add the lengths, multiply by the part outside. So 16 times 9 equals 64 plus 8x. Subtract 64 from both sides. So 16 times 9 minus 64 is 80. 80 equals 8x. X equals 10. Alright, in numbers 31 and 32, we have some circles inscribed inside of a polygon. So when this happens, this is from our tangents chapter. We know that we create some equal lengths here and here, here and here, here and here. So they're not equal to each other. I mean, the 2 ends aren't equal, but that's how tangents work. So here I've got a 5.7, so this must be a 5.7, which means this must be 11.4 minus 5.7. Okay, so that's 5.7. Which means this over here is 5.7, which means this must be 14.7 minus 5.7, which is 9. So now this missing piece right here is also 9. So now I have all the side lengths, so I can find the perimeter. So I'll add 14.7 plus 11.4 plus 5.7 plus 9, and I get 40.8. So I'm going to do something similar on the next problem. Let me zoom in on that. So I've got a 2.9 here, which means I've also got a 2.9 here. So this whole piece is 14.9, which means there's a 14.9 here. So I can find out this missing piece by subtracting that from 19.8. So now I can label this with a 4.9. So here's a 4.9. And so the piece that's left over from 19.8 is 14.9. And so since that's equal to that, I can label it. So now I know all the sides, all the lengths. So let's see if I can show everything. So I'm going to add, here I've got a 19.8. Here I've got a 19.8. Here I've got a 14.9. And then on this one, I just have to add those two lengths together. $72.3 altogether is what I get. In numbers 33 and 34, you've got a rule in the flip book when a quadrilateral is inscribed inside of a circle that opposite angles or opposite arcs are supplementary. Let me see if I can find that in the book. Since I don't have my flip book at home. Okay, so that is in the inscribed angles section. Corollary 3, the opposite angles of a quadrilateral inscribed in a circle are supplementary. So let's see how that helps us with numbers 33 and 34. So I know that angle C is 92, so angle F must be 88, because 180 minus 92 is 88. I've got a 96 and a 90 here. So altogether that's 186. So this angle here is inscribed around that 186. So the rule of inscribed angles is you divide that in half to get the inscribed angle. So if that's a 93, then I could find this angle that I want, because 180 minus 93, since they are supplementary, that's going to give me an 87 right there. And let's see if we can do something similar on number 34. First of all, I've got a 94 here, so that must make that angle 180 minus 94. So that's going to be an 86. Then I've got some arc lengths here. Oh, okay. So this 86, you can see that's inscribed. So this whole arc HGF is going to be double of 86. So that's going to be 172. So I've got HG is 108. So if I take that away from 172, I will get FG. So 172, let's see, that's 64. I can label that. Then this missing angle here that I'm looking for is inscribed around ZFG. So ZFG is 74 plus 64, or 138. So angle ZHG is going to be half of that. So half of 138 is 69. So angle ZHG equals half of 138, or 69 degrees. And we're on to our last one, and that is another sector area. So we're just going to use that formula, 240 over 360 times pi r squared, which is, what's the radius? 7. So 240 out of 360 is like 2/3 times pi times 49, which is 7 squared, equals 102.6. And since that's an area, we're going to name that in square kilometers. And that's the end of our test review.